this for me is a dream, and not just speaking at JSConf. This is my first JSConf, but typed JavaScript. It's a real dream for me, and somehow I found myself in the midst of this amazing proposal as one of the authors, one of the co-authors. So really, it's a dream for me, and it's great to be here and talk to you about it. So let's start. For me, what are the three biggest trends in JavaScript for the last 10 years? Oh, by the way, I'm 35 years, Tejas, not 30 years. There we go. Three biggest trends in JavaScript development, and I've been there since '95. For me, it's modern UI frameworks like React, Angular, Vue, etc. JavaScript tooling, the bundlers, the linters, the minifiers. There's a whole ecosystem that helps JavaScript. And third, and it's an amazing trend, which is TypeScript. The way TypeScript has evolved and made itself a huge part of the ecosystem. And this talk is about a formal proposal for enhancing JavaScript that will change forever the way we view TypeScript, the way we do JavaScript tooling, and the way modern UI frameworks will work. Really, I think this proposal, if it will be accepted, and I'm going to stop saying if it will be accepted, because in my heart I know it will be. But if it will be accepted, it will change the JavaScript landscape forever. Really, I believe it. So, what is a proposal? It's a proposal for adding types to JavaScript, which is amazing because JavaScript. So, who am I? Gil Tayar. As I said, I go all the way back to the 80s. I am not a boomer, I'm Gen X. On the other hand, I love to code. I still do it. I tried the whole management thing. Didn't work for me. Still a developer, still writing code to this day. I'm currently an architect at Roundforest, an architect as in a senior developer who's way past his age and is still developing, so you can't call him a developer, you just call him an architect. But I am also a member of the group that is writing this proposal, and actually the original author, which is, I'm still like shocked from the whole thing, with guidance from Little Dan, who helped me write the proposal and made lots of notes. But while I'm a member of the group, the opinions are my own. They are not necessarily the opinions of the members of this proposal. We're a varied group. We don't always think the same. No, we have people from Igalia, from Google, from Microsoft, obviously, from Bloomberg, and we don't necessarily think the same. So it's definitely my opinions. Take them with a grain of salt. And lastly, they're definitely not my employers, and I do not, and they asked me to add that. The TypeScript team are very much with us in this proposal for adding types to JavaScript team, but I do not speak on behalf of the TypeScript team. They asked me to put that. Okay. The proposal is officially part of the TC39. TC39, we'll talk about that in a second. It will get heavily shaped. It will not be as I talk about it here. There are no guarantees it will stay like this. So as I said, take it with a grain of salt. This is not the final proposal. It will absolutely not be. And this talk will be about this proposal. Where was it proposed? What is it? And why was it proposed? Okay, so it's a proposal for TC39. So what is TC39 for people that don't know? It's a committee for the standardization of, I'll call that, of the general purpose cross-platform vendor-neutral programming language, ECMAScript. So basically, the standard which we call ECMAScript, which is basically JavaScript by any other name, is TC39. That's where all the new stuff comes from every year. The process, by the way, is very transparent. You can access it in GitHub. You can see all the issues, all the proposals, all the meeting notes. It's amazing. There's a transcript of all the meeting notes. I'm probably one of the few just reads all of them, incredibly enough. And each year, a new JavaScript version comes out. ES 2015, 2016, 2017, ES 20, 21, 22, and examples of things that were added to JavaScript. Array at includes async await, top level await, flat map, and whatever. Carmel, can you bring me that bottle of water? Oh, thank you. Thank you. I'm not going to delve deeply into how features get accepted, But it's a process. It's a process that takes a lot of time. Stage 0 is where we were at March, where we thought of proposing type JavaScript, or what is formally called type annotations. Stage 1 is where it's accepted for consideration. That is where we're at right now. It's just, yeah, it sounds interesting. It's the committee saying, sounds interesting, maybe it's something that we can talk about. It's not accepted. Stage 2 is where, when we get to stage 2, the spec is almost complete. It's like ready. This is what the feature is going to be like. And if it's accepted, we do the final tweaks for the feature, finish the specs, and stage 3 is where it gets implemented in at least, I think, 2 implementations. Let's say V8 of Chrome and JSC, I think it's called, by WebKit or whatever, in 2 JavaScript runtimes, gets implemented, checked whether it works, whether there are things that we need to tweak, and once it gets to stage 4, boom, it's in the language. So let's talk about what is this proposal about. First of all, it was proposed to TC39 on March 31st, accepted to stage 1, as we said. So let's look at some JavaScript code. Add accepts 2 parameters, A and B, returns A plus B. Very simple. This is regular JavaScript code. This is the same code with type annotations. If this proposal gets accepted, then this will be legal JavaScript. You would not need to transpile it. It will just be accepted. You can copy paste it into the console and it will work. You can see there the type annotations if somebody doesn't know TypeScript or Flow or whatever. So will this pass? Yes, it will pass. This program will pass through JavaScript. Notice an interesting thing. This also passes. It accepts 2 numbers, but the first, when I call it, the first is a string, the second is a Boolean. Will this pass? And the answer is yes, because type annotations, according to this proposal, will be totally ignored by JavaScript. They will not, the JavaScript runtime will actually treat them as comments. The original proposal was called types as comments. We changed it to type annotations because it better reflects what we're trying to do, but the original proposal was called types as comments. The JavaScript will treat the type annotations just like comments. So basically, these are also legal type annotations, okay? Yes, sirree, these are legal, whatever. As long as they conform to a certain set of rules, and we'll talk about those rules later, they're fine by JavaScript. Maybe not by TypeScript, or maybe not by Flow, which is another type system, maybe not by Hegel, which is a third type system, which you may have or not have heard about, but they will be accepted by the JavaScript runtimes. And this is called, these areas where type annotations are possible are called the type annotation syntax space. It's a space that is reserved for type annotations, and where type annotations can be whatever they want to be as long as they conform to a specific set of rules. More type annotation syntax space is like type foo equals and the return value of a function. Those are more type annotation syntax spaces reserved for types. And not very coincidental, those areas are exactly the same that are reserved by TypeScript for types, okay? Exactly the same. And the nice thing about it is TypeScript and Flow, which is the second type system, which is also widely used, have basically the same space, type syntax annotation spaces. So it was very easy for us as a committee to reserve those spaces in our proposal. Okay, but just a reminder, this is not TypeScript. This is legal JavaScript according to the proposal. Wait, so why add type annotations if they're going to be ignored? I mean, what's the whole point of that? And the answer is, well, JavaScript runtime will ignore it, but the TypeScript and Flow and other type checkers and Visual Studio and whatever, WebStorm, they will not be ignoring it. They will look at the type annotations and tell you whether there is a problem in your types. Okay, so the summary of the proposal, and we will talk about the proposal more and go into details. Oops. Oh. Woo. So we reserve syntax space for type annotations. They are totally ignored by runtimes, but are not ignored by type checkers, third-party type checkers. And coincidentally, they correspond exactly to the same places that TypeScript and Flow use for types. So we announced the proposal on March 9th, and the internet exploded. I've been following proposals a lot, and there are proposals that are, from my point of view, as important, like records and tuples. They're going to change the way JavaScript is written forever, but this explodes because everybody wants to say something on types. It's amazing. So, but the nice thing is most of them were yes, and finally, and woo, and all that. But there was lots of criticism. And from my point of view, most of the criticism was really good. It was, and we'll talk about that. Some of it was unkind, some of it was difficult, but hey, this is the internet. I've tough skin. So let's talk about the why. Let's talk about addressing the criticism of why this proposal is there, and talking about the critics and what they were saying. So first of all, why add types at all? Let's start asking the question. This is not a trivial feature. Adding types to JavaScript, type annotations, is not a trivial feature. So if it's not a trivial feature, it deserves a non-trivial answer to why adding. It's not a, well, why not? You can't add that. And I give 2 graphs as an answer. And for me, they were amazing. And by the way, they were part of that explosion of the internet. People pointed me to these statistics, and it's amazing. So this is March 2022, the number of PRs divided by language, by programming language. As you can see, JavaScript and TypeScript had obviously were the kings of GitHub and the kings of open source. So give a big round of applause to JavaScript. Yeah. Notice that almost, if we take JavaScript and TypeScript as one language, JavaScript, which I do, obviously, almost half of the pull requests in GitHub in open source were TypeScript. That's amazing. That I did not know that, even when I started the proposal. A lot of JavaScript code is actually TypeScript. The community has embraced TypeScript, and these are, I mean, these are very, very, these are real numbers. This is not just hand-waving. The JavaScript community is using TypeScript, and they're used in the field. And if they're used in the field, they've probably proved their value to the community, to all of us. Let's take some others. The state of JavaScript. Static typing in 2020 was the most missed feature from JavaScript by far. In 2021, it was less, but it's still number one. It's still number one. People want static types. People want type annotations in JavaScript. So a large part of the community wants that. So is it worth the complexity? I say absolutely. If it's a feature that the community uses and uses heavily, we should start thinking of incorporating it into JavaScript. But I got more criticisms, 3 more criticisms about why not to add types to JavaScript, and they make sense. Well, most of it. Types are difficult for beginners to grasp. That's true. Okay, we'll talk about that. Types increase the payload in web apps. I don't understand that, but we'll talk about that. And I don't like types. Types are shite. Let's start with the first one. Types are difficult for beginners to grasp. Yes, JavaScript is easier because you don't have to think about types. It's true. If you start from JavaScript, then adding TypeScript is difficult. But if you start, and if this proposal is accepted in 5 years, everybody will be starting from types, then it may all make sense. And it's not that difficult. I started from C, C++, Java. Okay, well, I did start from BASIC, but let's ignore that for a second. But I got types. Most people get types. My daughter, she's 16 years old. She's studying Java. I'm sorry, but that's what she does. Yeah. Sorry, Oracle. But she's getting types. It's not that difficult. So yeah, maybe a bit. And this somebody that teaches JavaScript is saying something interesting. New programmers searching for example code are likely to find TypeScript and flow examples and then wonder why it results in an error when viewed in their browsers. So people today, juniors today, are struggling because a lot of TypeScript, a lot of code examples are TypeScript. In other words, whether we want it to not or not, types annotations are everywhere, so they need to be incorporated. Types increase the payloads in web apps. I'll just put it, yes, the program will be bigger in size and bytes because there are type annotations, obviously, but there are also comments and white space. Indentation also increases payload. And what do we do about that in production? We use what? What do we use to make our code smaller? Minifiers, exactly. And minifiers will obviously remove the type annotations as well, so no problem. But in development time, I won't pay the price for transpiling. So development time which will be nicer, and I don't need to minify during development. And the last one is I don't like types. I know. I was there. I was a JavaScript junkie, and I left Java for JavaScript, and it was like, oh, static types are bad, they're really bad, and I was like trying to convince everybody, and I was there. But I don't care about me. I care about you. I care about the community. And I'm a type fan now, okay? But even if I wasn't, this is not about me. This is about the community, and the community wants types, and the graphs show that very well. Okay. So, we want type annotations. I've convinced you of that. But there are the people who say we already have TypeScript. Why do we need to extend JavaScript? We can still use tooling. Why not just continue using tooling? There are three answers. Language, not tooling, the philosophical answer. And this is me getting all mushy. And we have forgotten our roots. You weren't born during the roots of JavaScript, most of you. But we have forgotten our roots in scripting. As we write some code, we press F5, refresh, Command R, and boom, it works. That was how we started. That is how JavaScript became big as a scripting language, just like Python and Ruby. We have become addicted to tooling. And this is absolutely my own opinion. People love tooling. I don't get it. We cannot not use it anymore. I'm okay with tooling. Minifiers are great. Linters are great. But today, we cannot not use it. If I want to create a React app today, there's only one way to do that, and that is create React app or any one of those template generators. I cannot build a React app or a Vue app or an Angular app without this complex tooling which I do not understand. I'm writing here, junior developers don't understand this tooling, and that's not true. Senior developers today don't understand the tooling. And it's not their fault. It is not your fault for not understanding. It's very, very complex. Tooling is now cargo code. We used to not to need it. We don't need, there are ways to avoid it. And this proposal is part of the way to avoid tooling. Philosophical answer. The people that use TypeScript are coding in one language, TypeScript, but running it in another language, JavaScript. This is unheard of in any language except JavaScript. This is bad. And we're reaching a fork where TypeScript is going this way and JavaScript is going this way. And that is not bad. We need to mend the rift. We need to mend the fork, bring them back together. And there's the pragmatic answer. TypeScript is everywhere. And because TypeScript is everywhere, all the tooling needs to accommodate it. It used to be that tooling only used to do JavaScript, and they don't care about TypeScript. But now, most toolings now, they understand TypeScript. And anytime TypeScript changes, they need to accommodate its changes and understand these changes. And that is bad. Tools need to involve with JavaScript, with TypeScript, and that is not good. And it's part of the reason why TypeScript today has a monopoly on types, because you can't do anywhere else, because all the tooling is working with TypeScript. And this proposal simplifies the tooling tremendously, because there will be a very simple set of rules to ignore the type annotations, and tooling will be able to use it once and forever. And the political answer is, I believe TC39 should be the arena for enabling type systems. Not necessarily evolving them, but enabling type systems that will be basically in everyone's JavaScript code in the future. Okay, so convinced you that types are part of the language, but this will not enable us to standardize types in the future because today we're saying we're ignoring types. So if we want to standardize some kind of type system in the future, we won't be able to because once we ignore types, that's it. We can't go back, which is true because of backwards compatibility. JavaScript has to be always backwards compatible. So whatever you put in the type annotation syntax space will be ignored now and forever. But I say when the need arises, if we do want to standardize a type system, we will find a way. I know TC39 doesn't like pragmas and use types or whatever, but some kind of a way, if we need to standardize the type system, will be found. And the last thing is, why stop? That's the, okay, if we're going to do types, then let's do them all the way. Why stop at ignoring them? Why not fully embrace TypeScript? Why not build a type system of our own? Why not do runtime checking so that, runtime will throw because the parameters are bad? And why not optimize? So why not fully embrace TypeScript syntax? This is a good one. Everybody is using TypeScript. I mean, Flow is used heavily, and most of the code you run in Facebook is Flow. But TypeScript is the de facto standard today. Why not go all the way? One, it's still evolving. And I, for one, want Microsoft and others to continue evolving. Type systems in JavaScript are complex. We need to research and evolve that area. And if we embrace it and put it in TC39, that stops the evolution on its tracks. And I don't want that. I want them to continue evolving and checking and making it better and better. And if we do TypeScript, that's it. That's TypeScript. But if we don't, that will enable other type systems to flourish. Hegel, Flow, and probably others that will flourish and maybe overtake TypeScript one day. And this is good, ending the monopoly on type systems. And TypeScript is huge. If we want to standardize it, it'll take 20 years. It's so big that it will never be standardized. Not really. So why not build a type system of our own? We have a proponent of that sitting in the front row here. He will be a speaker in this conference. So why not build a type system of our own? Let's make it simpler. TypeScript is so complex. And the other people say, let's make it cleaner. TypeScript is so weird. So TypeScript is too complex. Let's make it a simpler one. Let's make a very simple, accept numbers, accept Boolean, accept an object with these fields. Yeah, why not? That's it. We don't all need all the complexities. But the complexities of TypeScript are there for a reason, because TypeScript wants to make it be the type system for JavaScript and to have all the JavaScript libraries, the current ones, be TypeScript compatible and tell us, for example, pick in Lodash. We want this to be an error. Okay, pick object, pick two fields A and B, .c, that should be an error. That's not a simple type system. And basically, most of what TypeScript is doing is evolving towards making all the libraries, all JavaScript, be type compatible. And it's difficult. What about making it cleaner, like Haskell or Camel? The reason they have a very, very clean type system, very, very small, very nice, really. If you use Reason or OCaml or Haskell, it's like, oh, this is so nice, this is so small. But we're not using Haskell, we're using JavaScript. And to be a type system for JavaScript, we can't make it simpler, we can't make it clean because of what I said earlier. It won't work. Why not do runtime checking? Because TypeScript today doesn't do any runtime checking. Well, it just clears out the types. It just only does compile time, build time. So no checking. Having said that, TC39 suggested we do some check to check this route, so we will be checking it. And let's optimize based on the types. If we know that it accepts two numbers, why not optimize? I don't want to get into that. There's a whole Twitter thread on that. In the comments. Okay, what about the what? Let's go. And as I said, this will undergo considerable change in the future, so don't take it as it is. Okay, so let's start talking about the syntax space. What exactly will be in and what will not be in the proposal? What is in the proposal and what is not in the proposal? First of all, functions, arguments. You have to specify the arguments of the you can specify the type of the argument. But that begs the question, where does the type end? How does JavaScript know to ignore the types? Where does does it search for the comma at the end of the argument? It can't search for the comma because the type itself has a comma. Okay, so how does that work? How does it ignore? In comments, it ignores because it searches for the // but here, how does it ignore? And the answer we've come up with, and again, it may change, we do search for the comma, kinda, but if there's a bracket, like a parentheses or a square bracket or an angle bracket or whatever it's called, then we start counting and balancing the parentheses, okay? And whatever is inside those parentheses, we just ignore it. So that's the current proposal of how we ignore types at runtime. We look for whatever needs to be at the end, but we look, if we find some parentheses, then we start counting and balancing them and ignoring whatever is in the middle. And this will allow continued evolution of type annotations without breaking JavaScript compatibility. So TypeScript and Flow and Hegel and others will be able to play in this space. And some TypeScript and Flow types will not pass. Okay, this parsing. So we can always surround them with parentheses. And it works, by the way. I checked when I was writing the proposal. Any type in TypeScript and Flow, you can just add parentheses and they still work. So as I said, some TypeScript will need to be rewritten to accommodate this, but very, very slow. So we were talking about functions. Variables, the type of the variable. Types, where you can define aliases. For example, this pair. A pair type, interface, just like in TypeScript. I've never understood why there's both interface and type, but whatever. Class properties, just like in TypeScript and Flow. Generics, very important. I think this is important. Today, a language without generics is not really there. Importing and exporting types, that's possible. We've also added it. But there are some that are problematic, and we don't really know how to deal with that, and we'll flesh it out during the stage 2. Casting. Casting in Flow is not low, Flow, sorry. That's the bottom one, and the top one is TypeScript adds something. We need to figure out, we incorporate both of them, we incorporate one. I'm all for the top one, not because I like TypeScript, because I think it's easier to explain. Generic function invocations. This is valid TypeScript. It is not valid JavaScript, by the way, because JavaScript will look at it as like do something is less than number and is also bigger than blah, 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 blah. This is not, and TypeScript knows that. And they are willing to change TypeScript. For example, adding the double colon there. They are willing to change TypeScript to accommodate this to be okay. This is please, for the TypeScript team. I feel like they're part of the community. The TypeScript and Flow teams are part of the community, and they're all there for the community. This parameters, it collides with another proposal that is in Tc39. Declarations, actually, you can't put it in a TS file. You have to put it in a DTS file, but some people are talking about that. Function overloads, that's a big problem. How do we deal with that? A function without a body. Oh, I don't know what to do with that. Abstract classes. That has semantics that maybe have runtime semantics, so what do we do with that? And member modifiers, they're just stuck in the middle of the class declaration, like they're ugly. What if we want to add? TypeScript, and we have suggested maybe adding a sigil to them, like %public, and then JavaScript just ignores whatever is after the %. Things that will not be in the spec, enums, namespaces, parameter properties, JSX. Why are they not there? Because they're not just type annotations. They write code. An enum is code for an object. If you think namespaces also create objects, they will not be part of the spec. But anyway, TypeScript says, please stop using that. That was a mistake. The consequence, if this proposal lands, no more transpilation, no more need of transpilation of most TypeScript and Flow. And if we use real browser ESM, we will finally remove all tooling. We'll still be checked by by third-party types. There will be slow convergence of incompatible TypeScript and Flow to this proposal. Tooling will become much simpler. Other type systems, hopefully, will be experimented with, but it will take time. It will take years. But I hope this proposal lands. It will be worth the wait. Thank you very much.